very good morning to all and a very happy new year. On behalf of the director Dr. Vanna Prasad and my own, I welcome you all to the 8th Dr. B.S. Venkatachala Memorial Lecture on the occasion of the 88th birth anniversary of late Dr. B.S. Venkatachala, former director BSIP. May I now request our director Dr. Vanna Prasad to pay floral tributes to late Dr. B.S. Venkatachala. Thank you, ma'am. May I now request Dr. Santosh Shah, Convener Scientific Events and Coordination Committee, that is SECC of BSIP, to provide audience with some information on the lecture series, the professional life and conduct of late Dr. B.S. Venkatachala.
Good morning. Today I am here to talk about something about Dr. B.S. Venkatachala and also about the lecture series which is going to be held today. Dr. Bengaluru Sri Nivasarao Venkatachala, popularly known amongst his paleobotanist friend as Chala. He was born on 2nd of January 1933 in Bangalore, a city known for literary and scientific activism. He had a distinguished career spanning almost 4 decades, devoted to the science of paleobotany. He was well known for his wider interest on the past life, ranging in age from Precambrian to Tertiary, and made pioneer effort towards development of palynology for all exploration in our country. During his long scientific career, Dr. Venkatachala published more than 100 research papers and supervised many palynological research projects in search of petroleum source rock, co-authored 2 volumes of memoir, Geological Society of India on Palynology in hydrocarbon exploration in Indian scenario. He has also edited 5 volumes of research publication in the field of paleobotany and palynology, beside Indian Gondwana Memoir 21 of the Geological Society of India. He retired from this institute at the Bilvasan Institute of Paleosciences, which was previously as a paleobotanist, in 1993. Dr. Venkatachala passes away on 15th of June 2007 in Dehradun. Since 2008, on the day of 2nd January, the birthday of Dr. V.S. Venkatachala, a memorial lecture was organized every year. In every alternate year, Dr. V.S. Venkatachala Memorial Medal is awarded in recognition of outstanding piece of research work in paleobotany and allied such aspects to the young scientists, including Bilvasan Research Scholar and Research Associate and Project Scholar of this institute. And in alternative year, researchers from outside and also from inside the institute deliver memorial lecture on paleobotany and allied aspect. Thank you very much.
Thank you, Dr. Shah. I now request our director, Dr. Vanna Prasad, to share her views with the audience on today's occasion.
Good morning, and again very happy New Year to all of you. So as we know that today we are going to have a B.S. Venkatachala Memorial Lecture. Dr. B.S. Venkatachala, he was a renowned and very finest scientist of this institute. And he was also director of this institute from 1985 to 1993. As just now Santosh has told us about his areas of research. So he has carried out research in the diverse areas right from Precambrian to Cenozoic time span, and in diverse fields such as palynology, biostratigraphy, biogeography, plant biogeography, and in areas of hydrocarbon exploration research. So he was very enthusiastic about all the research which is being carried out in the areas of paleobotany, and he used to encourage students and young researchers. So in 2008, Institute has instituted a medal on his birth anniversary and a memorial lecture for young researchers and renowned scientists who are doing excellent research in their field for and to present their work for wider audience. So today we are going to have Dr. Sayak Basu, who is going to present his excellent piece of work in the areas of geochemistry, and we are very hopeful that everybody will enjoy his lecture. Thank you so much.
He has a wider interest of research in stable isotope enabled organic geochemistry, isotope hydrology, carbon cycle, and paleoclimatology. He has awardees of different achievements. Recently, he has received the INSA Medal for Young Scientist 2020 from Indian National Science Academy, National Postdoctoral Fellowship in 2019, Science and Engineering Research Board. He served as a postdoctoral fellow in Earth and Environmental Sciences in Indian Institute of Science, Education and Research, Mohali, ISM Mohali. And thereafter, recently, current position, he is availing in National Postdoc Fellow in Geological Ocean Department in National Institute of Oceanography, Goa. With this brief introduction, I would also like to mention that being a young researcher, he has created landmark publication for his name in a very short age. And with this brief introduction, we congratulate Dr. Basu for receiving Dr. B.S. Venkatachala Memorial Award and would like to him to now deliver his talk on the topic, a very, very interesting topic, that is, what does compound specific stable isotope tell us about the past environment conditions? May I now request Dr. Basu to deliver his presentation.
Good morning, everyone. Thank you, Director Ma'am, Senior Scientist, and other BSIP staff for inviting me to present in such prestigious platform. Today, I'll be talking about what are the extra information or insights that compound-specific stable isotope provide us, and how they can improve our understanding about past environmental conditions. Honestly speaking, I am not very much habituated with this virtual form of presentation. So at any given point, if you face any difficulties with sound and visuals, kindly interrupt me and point it out at that moment. Now, coping up with the new normal has never been easy, and especially when you are fighting against the nature. We, the Indians, living in a country where our livelihood is shaped by monsoonal rainfall. To be very specific, the Indian summer monsoon, during which period most parts of the country receive dominant fraction of its annual rainfall budget from June to September. Now, we are coming from a very diverse country, right? Like our food habit, our language, our rainfall distribution is also spatially heterogeneous. Not only spatially heterogeneous, but its temporal trend also varying from one location to other. In one part, we are seeing significant precipitation increase, whereas in the other part, we are seeing precipitation decrease. Precipitation, but also temperature over the superficial landmass.
Dr. Basu, we can't see.
So similar to rainfall, our temperature change over the country is also spatially heterogeneous, and most part of the country is affecting by a significant temperature rise coupled with CO2 hike. Now, all these changes are affecting our livelihood by creating more vector-borne diseases. It affecting our crop yields. We are experiencing more frequent extreme events like in the form of floods or droughts, and ultimately all these factors are affecting our food production, agrarian economy, and as a whole our sustainability. So to have a better future, we always need to be certain about these climatic changes, and towards this several research have been conducted so far. Some of them coupled these changes to the land sea thermal gradient weakening, some coupled it with the subsurficial heat budget change in the adjacent oceans, and then ultimately transfer this knowledge to develop climate models so that we can be prepared for this future. Unfortunately, what we have seen that this model outputs exhibit a significant offset with the Gauss data observations, implying there is a lacuna associated with our present understanding and there is an inadequate parameterization in the existing climate models. Now, why so? First of all, these climate models are basically developed with the help of gridded climate variable dataset available from various platforms like Indian Meteorological Department, Climate Research Institute, TRMM, etc. Although these datasets are providing us records at a very finer spatial resolution, sometimes even at 0.25 into 0.25 degree spatial resolution, but they cannot extend back temporarily up to last 150 years. And within this 150-year time span, we have influence from both human and anthropogenic activities. And sometimes it is pretty hard for us to tell the relative contribution of these two factors onto the hydrological system or the ecosystem as such. So therefore, we require a data set that can extend back beyond the scope of the instrumental record. Our science has advanced a lot, but yet we failed to invent a time travel machine, so we cannot go back and see what has happened in the past. In such case, we need to rely on something that can inherit the signature of previous environmental condition. We call them proxies. There are abundant proxies available nowadays, uh, like biotic proxies. Your institute is quite famous for using them, like pollen or phytolith. There can be sedimentological proxies as well. Although these proxies are beautifully capturing the climatic pattern, but they are mostly qualitative in nature. Suppose if I am using a sedimentological parameter such as grain size, I'll be able to tell about the climatic change. Fair enough. Lower the grain size, finer the grain size, lower the transportation energy, and implying a drier climatic spell, vice versa. But how much rainfall change has taken place, whether that is 200 millimeter change, 300 millimeter change, so on, we cannot infer from such proxies. And that's why we need to have another proxy that can quantitatively tell us about such climatic changes. Towards this, I have used the geochemical proxies, like the stable isotopes of various geological material. Now, the isotopic proxies are commonly referred via delta notation, which is basically the ratio of isotopologues, heavier and the lighter isotopologues. And mainly I have used three stable isotopes: carbon 12C and 13C, oxygen 16 and 18O mainly, because the abundance of 17O is extremely low in atmosphere, and the hydrogen, protium and deuterium. Now, the relative distribution of these isotopologues into different geological materials are extremely process driven, and we can easily quantify them in nature. And that's why by measuring them, we can have some idea about how does the climatic change in a quantitative manner. Now, the most commonly used climatic proxies or the ecosystem proxies are the isotopic composition of soil carbonate and the soil organic matter. Now, if we measure the oxygen isotopic composition of the calcium carbonate, you can actually backtrack the oxygen isotopic composition of rainwater. Similarly, if we measure the carbon isotopic composition of soil carbonate or soil organic matter, you can actually backtrack the carbon isotopic composition of the overlying vegetation. So what we do, we go to the field, we collect the sample, we measure their isotopic composition. But these are ultimately some numbers, right? And until unless we don't have any mean to understand why such numbers are varying, those numbers are pretty useless. So towards this, what we use a very fundamental principles of geology that present is the key to the past. We see what is happening in our modern day system. Like for the interpretation of delta 18 value of soil carbonate, we first see what is happening in the delta 18 value of rainwater. Large calibrations have already shown that in the low latitude tropical region, if we increase the rainfall amount, the isotope value, oxygen isotope and the hydrogen isotope value of the rainwater will go down. Suppose if we increase the rainfall amount by 100 millimeter, your oxygen isotope value will go down by 1.5 per mil. This effect is popularly known as amount effect. Now, this amount effect serves as the basis of interpreting isotope and isotope based climate reconstruction. Suppose in a geological material, if we are seeing a lower value, we couple that or infer that as a form of wet climatic event, and vice versa. Same is true for the vegetation reconstruction. When we say the vegetation reconstruction in terms of the isotopes, we basically talk about the C3 and the C4, their relative abundance changes. Like their photosynthetic pathway and in environmental condition, C3 and C4 plants have the unique isotopic compositions as well. Previously, it has been postulated that the global mean of C3 value is around minus 27 per mil, whereas that for C4 plant is around minus 13 per mil. Now, we simply use such mean value as an n member in a binary model, and that's how we can backtrack the relative abundance of C3 and C4 plant in the past ecosystem. But all these values were previously available or measured from different parts of the world. When with Dr. Sailesh Agarwal from BSIP, I have started to prepare the modern calibration for the India. I have seen that the values are quite negative compared to the global mean. It is at least minus 2.5 per mil more negative. Why so? Uh, is it some measurement uncertainty or some unique characteristics of the Indian plants, or there was an uncertainty or error associated with the previous methods? Towards this, what I have done, I have prepared so for the largest global database for the carbon isotopic composition of C3 plants, and I have seen that the isotopic value of the C3 plant changes with the rainfall amount for a certain rainfall range, that is mean annual precipitation up to 1500 millimeter. Within this range, del 13C value of uh, isotope changes minus 3.3 per mil for every 100 millimeter increase in rainfall. So we mentioned that region-specific calibrations are foremost for this kind of paleoclimation reconstruction. Although these proxies have served us quite beautifully for solving different parts of the problem, but they are quite well associated some errors as well. Like carbonates, carbonates basically formed in arid or semi-arid regions. Like I'm from Kolkata, if I try to have a climate reconstruction using soil carbonates, I can't. Kolkata being in a humid climatic region, there is no occurrence of carbonates. Similarly, sometimes we have seen that there is an offset in the C3 or C4 plant estimates when you compare the records from soil carbonate and soil organic matter from the same profile. Why so? Because earlier it has been believed that plant residue after their death incorporates into the soil without any uh, degradation or any fractionation, isotopic fractionation. However, in reality, the organic carbon is a conglomerate of several compound classes like lipid, lignin, amino acid, pectin, etc., and each with specific vulnerability within the soil environment, also with distinct carbon isotopic composition. Suppose if I measure bulk carbon isotopic composition of any profile, it is basically an amalgamation of lipid, lignin, and carbohydrate. Now, if I preferentially remove carbohydrate from the system, which is, by the way, the reality, carbohydrate is the least stable within the soil environment and they degrades faster compared to the lipid and lignin, which are considered to be the more recalcitrant compound classes. So, due to that isotopic difference, if I remove the carbohydrates from the system, our bulk isotopic value will be going down due to the enrichment of lipid and lignin into the system. You can clearly see from their isotopic values. So in such case, if I measure the bulk carbon isotopic composition of that particular sample, I will get a false idea that there would be a more abundance of C3 plants due to the lower isotopic composition. But that will be far from the reality. Another problem is that this proxy is applicable only when there is a certain organic matter source. As I mentioned earlier, we use them in a binary equation to get the relative abundance of C3 and C4 system. So ideally in the system, there should be only the C3 and C4 plant derived organic carbon be there. But in reality, suppose you are working in a marine or in lacustrine system, you will get signatures from other organic matter sources like aquatic plants, soil microbes, marine phytoplanktons, etc. Like the one I have just measured from marine core sediment from KG basin. Just take up any value, like for an example, minus 21.3 per mil. It is basically again another conglomerate of C3 and C4 plant, marine phytoplanktons, etc. Now forget about the degradation. Only even it's retaining the pristine isotopic signature, we still cannot disentangle the relative contribution from C3 and C4 plant because it is sourced from multiple organic matter. And that is why we need to have a proxy that is omnipresent, that is source specific, and that is less prone to degradation. Lipid biomarkers can be one of such proxies because every living organisms produce lipid to serve one or other of its purposes. From our skin to plant leaf surfaces, everywhere you can find the lipid. Now, lipid is composed of several organic compounds like uh, fatty acid, alcohol, alkanes. Among them, I have used the alkane. One of the reasons for using alkane is their simple structure, and that's why they are very less prone to degradation. Another important point is that this is a characteristics of typical lake sediments or any soil sediment profile of in alkane. Now you can see that in the x-axis you can find several carbon compounds. In the y-axis you can find their concentration. You can see that there is a pattern. Now in this, all these alkane chains are basically pinpointing towards a certain organic matter source. When it is a short chain following within the 12 to 20, it is basically sourced from the microbes. When it is coming from the aquatic plants, macrophytes, it has a characteristics of 21 to 25. And when it is sourced from a long terrestrial plant, it is characterized by their presence in the long chain. Now this is a characteristic spectra of a long chain analkane. You can clearly see that there is a dominance only in the longer chain, whereas in the shorter chain you cannot find any significant contributions or a significant presence of any other homologue. Another interesting part is that you can see from their respective carbon numbers that the concentration of 29, 31, 33, 35, the odd number of carbons have a higher concentration compared to their adjacent even numbered carbon. This odd over even preference is another signature of their pristine characters. If this odd over even preferences diminishes over the time, that means that the organic carbon has suffered degradation and we cannot use such alkane even for the climatic reconstruction. So they are very easy to use as well. So what we do in reality, we just transfer this knowledge to prepare some indices. Like here you can see that in the longer chain, the odd over preference that is reflected in a proxy called carbon preference index, abbreviated in the form of CPI, it is greater than 1. It signifies that the terrestrial derived organic material has not been degraded. There is a P aqueous value, basically that is the 21 plus 23 divided by the long chain analkanes, odd numbers. Its value shows that there is a significant presence of aquatic plant and a higher concentration of 18 or 20. This signifies that it has suffered or it has a contribution from the microbial activity as well. So from a single proxy, we can tell about multiple organic matter sources as well as their relative contribution to the system. Now, ideally what we do, we go to the field, we collect the sample, we dry them, then We use them in a accelerated solvent extractor using certain chemicals. Here we used polar solvents like DCM and methanol to extract the total lipid content in that particular sample. We then transfer that to a column filled with silica gel. We use hexane as an elutant to extract the total N-alkane concentration in that particular sample. Then for the quantification part of the source characterization, we introduce them in a GC system coupled either with MSMS or FID as a detector, and we get the characteristic spectra. We get some idea about what are the organic matter sources, and then we introduce that particular sample to a GC coupled with isotope ratio mass spectrometer to measure their isotopic composition, both carbon and hydrogen one by one. Now, towards this, we have established the first isotope-enabled organic geochemistry laboratory in an academic institution of India. And as far my knowledge, we have published also the first data set of its kind from any Indian laboratory. And I believe that your institute also have similar kind of facility, and such kind of analysis can be conducted in BSIP as well. Now, so far we talked about the theoretical part. Now let's apply them in the reality. Towards this, we have collected samples from grassland, which is basically the largest grassland in the Asian continent, the Bani grassland. We collected some peat sediments from different wetlands in this Bani region. We, after constraining the chronology, we measured their carbon acidic composition in the long chain homologue. And we have observed that over the last 5,000 years, there is a change in the carbon acidic composition, implying there is a change from C3 to C4 plant abundances, and there was an expansion of C4 based grassland taking place for at least last 3,000 years. Now, when we have done the same analysis for a different lake located in the southern peninsula of India, our results were not similar. Now, this lake is located in the southern India, and here the dominant fraction of rainfall is being received during the winter months. Now, when we plotted them together, we have seen that they are going in an opposite direction. While all the ISM based records are showing an increase towards this C4 plant, here after 3,000 years in the northeast monsoon dominated region, we are seeing there is a steady increase of C3 plants. Now, why there is an offset? Why both ISM and NEM vegetations are going in an antiphase relationship? Towards this, again, we seek the help of modern climate. We have seen that not only the vegetation, at least for within the scope of instrumentation record, the ISM rainfall over the north central part of the Indian subcontinent and northeast monsoon rainfall over the southern part of the India are showing an relatively antiphase relationship. So again, another question whether this change is just a recent phenomena or a long-term phenomena. And here comes the most importance of compound-specific isotopes or stable isotopes as a whole. Here, any other proxy will not work, because here the rainfall is received during both ISM and northeast monsoon. So until unless we characterize the vapor sources and their relative contribution to the system, we cannot infer directly about these climatic changes. So towards this, what we have done, we first installed a rainfall collection station at a nearby location that was in Chennai. We measured their isotopic composition, and we have seen that compared to the ISM rainwater, the northeast monsoonal rainwater is characterized by a relatively lower isotopic composition. So if I am working in a geological inventory, their lower isotopic composition will infer us about a more strengthened northeast monsoonal rainfall, which is sourced from Bay of Bengal. Now, with this in mind, we have prepared the hydrogen isotope-based N-alkane record, and there we have seen that there is a relatively gradual increase in the rainfall pattern, northeast monsoonal rainfall pattern, is taking place in the southern part of the India for the last 3000 years, and which is in an antiphase compared to all other boreal summer monsoon records. And we have also observed that at the same time there was more frequent El Nino events was taking place, and the correlation between El Nino and Indian summer monsoon rainfall is quite well established. More the El Nino, lower the Indian summer monsoon rainfall. Whereas the correlation between the El Nino and Northeast monsoon is kind of debatable till date. So what we have observed, we again seek the help of modern records and have observed that during El Nino time, the northeast monsoon is intensifying over the years. And this is basically due to the fact that during El Nino event, a pressure gradient forms between Arabian Sea whirlpool and the Pacific Ocean, tropical Pacific Ocean. And due to this pressure gradient, easterly jet becomes strengthened, and when this easterly jet superimposed over this northeasterly wind, it helps more moisture to pick up from the Bay of Bengal, and that's how we get more intensified rainfall over the southern peninsular India during the winter months. And that's how this whole El Nino is creating an antiphase relationship between Indian summer monsoon and winter monsoon for at least last 3000 years. Now, the beauty of this compound switching isotope is that its application is not only limited in resolving problems limited to this Holocene or even Quaternary timescale, as it is very much less prone to degradation, we can find its pristine signature in the older samples as well. And that's how it has a wide range of applications, starting from forensic science to solving different problems in other geological timescales as well. Like one of my colleagues actually uh, refined this whole C4 plan evaluation in the Indian Shivalik region using the same proxy for the Miocene timescale. It has a great advantage when you are talking about the boundary problems, and in the boundary condition the atmosphere has power dot maximum, and this is readily being can be readily being captured by this isotopic composition in the N-alkane or other lipid biomarkers like fatty acid and everything. So based on this wide range of application, composite isotopes are nowadays becoming extremely popular in solving different scientific problems, and nowadays most of the labs are trying to equip them with such facilities. Now we have tried to provide another caution before using such tools for any sort of interpretation, because the response is extremely vegetation specific. Similar to the bulk carbon isotope, nowadays I'm also preparing the carbon isotope composition of C3 plants for this N-alkane, and I have seen that the angiosperm trees or the gymnosperm trees, they are characterized by a different isotopic number. So when we are talking about past ecosystem condition, you shouldn't be done blindly. It shouldn't be done blindly, and it should be coupled with other proxies. Like I must say that here biotic proxies would be ideal. If we couple them together with the help of biotic proxies, we can actually identify what type of plant was there, and then if we add the isotopic values, we will get a more refined uh, idea about these past changes. And also one thing we need to take care of, that their responses, these plant type wise responses to the environmental or abiotic stressors are quite different, and that's how this whole coupling of biotic and the abiotic proxies are more important. Like different plant types have uniquely respond to their climatic stressors in a different manner, so these things should be taken into account for final interpretation. We have tried to share this knowledge in terms of publications and everything that is quite well known for everyone, well known practice for everyone. We are also nowadays trying to provide this information for the non-academic persons as well, using the social media handles. And if you want to contribute your findings, and if you want to try your convey your message with the non-academic persons who are interested or who could be interested in science, you can please contact us or provide your contribution to these social media handles. And the last, I would like to thank all my previous lab mates and the funding agencies for helping me to complete the research and providing me great inputs during the time of the research as well. Thank you.
Dr. Vivesh, I have a very pleasant duty. I'm here to propose a vote of thanks on successful completion of today's memorial lecture. On behalf of the Director, Birbal Sahni Institute of Paleo Sciences, Dr. Vandana Prasad, and Scientific Event Coordination Committee SECC, and my own, we're thankful to the staff members of the Institute for online celebrating and memorizing 88th birth anniversary of renowned paleobotanist, late Dr. B.S. Venkatachala. We are grateful to the speaker, Dr. Sayak Basu of National Institute of Oceanography and IO, Goa, for delivering the Dr. B.S. Venkatachala Memorial Lecture. Any function could not be successful without the support of various authorities of the institution, and we acknowledge the support of Computer Auditorium, Staff Welfare, Photography, WNB, Walks-in Building, and Website Committee for successfully organizing this event. We also thank to the Registrar, Mr. Sandeep Kumar Shivhare, and administrative staff members for providing support to organize this event. Once again, on my behalf, I am thankful to all of you for your presence in 88th birth anniversary celebration of late Dr. B.S. Venkatachala. Thank you so much.